Algebra 2, Unit 1, Day 4. We are going to take linear functions and we're going to bring them into real-world application. So here we go with your note sheet. Just little reminders that the x-coordinate or the x-axis, horizontal axis, is going to be used for your independent variable, and your dependent variable will be on the y-axis, the vertical axis. So here's an example of a nice little linear equation. And it says label the independent variable and the dependent variable in the question below. Then create a situation that could have the following equation. Okay, so if you think of the independent variable is where the x-axis would usually be. It doesn't have to be the letter x, but if you're talking about x-axis, y-axis, independent would be where x usually is. And this looks like almost like a y equals and then mx plus b. So this letter, this variable right here, is going to be our independent variable. Okay, our independent variable. And our dependent variable is going to be this capital T. Okay, that's going to be our dependent variable. So could you imagine a function that begins with 80 units of something? Could be $80, could be 80 pounds, it could be 80 miles, right? And it's consistently decreasing by 2 units for every unit of either time or distance or whatnot, whatever m would represent. So we just have to think of something in real life that could be represented by this. So let's say that it costs $80 to buy a certain pair of shoes that you're looking to purchase. By the way, I think that's way too much for a pair of shoes, but I do know what they go for nowadays. So let's say that this is the initial amount of money that you would need for the shoes. And if you want to write what I'm saying down here, that's fine. I'm not going to write it all, but let's just say that this is the initial cost of the shoes. And let's say that you're going to pay $2 a week towards the shoes, or you're going to save $2 a week, all right? So this is the rate of change. If it's a line, that would be a slope, right? But this is how much money you're going to save per week, right? And then M would be the number of weeks, right? So if you take the initial cost of 80 and you subtract $2 times however many weeks have gone by, then that means that this capital T is going to be the amount of money that you still owe, or the amount of money that you still have left before you can purchase to buy your shoes. Okay, and you can make up a word problem with something other than shoes. It's just giving you a quick example of how you could take a linear equation and relate it to something that is an everyday example. Okay, speaking of example, let's look at example 1 here. It says a construction crew is lengthening a road. The road started with a length of 53 miles. Okay, and then it's adding 4 miles each day. Okay, it's adding 4 miles each day. Okay. Now it says let L represent the total length of the road in miles. Let D represent the number of days that the crew has worked. And then it says write an equation relating L to D and use the equation to find the total length of the road after the crew has been working for 32 days. Okay, so which of these is my independent and which is my dependent variable? Well, I would say that the amount of road would depend on how many days. So L and D are my variables. So I wouldn't say that, okay, we have this much road, that affects the number of days that are passing. Okay, the number of days that the construction crew is working, that affects how much road they are putting down. So we'll say that L is my dependent and D is my independent variable. So that means our equation is going to start off with L equals. So the length of the road equals. Now up here we had an initial amount. Well, what's the initial amount that they're starting with here in this word problem? Well, it says they started with 53 miles. So 53 miles is how much they started with before they started building more road onto this construction area. Right? Now, notice we also had the rate of change. Okay? We were paying $2 or saving $2, so that was decreasing $2 from how much money we needed to buy the shoes. So the reason that the 2 was negative, the reason that's a -2, is it was making our initial amount decrease. Well, is our initial amount going to increase or decrease if we're going to get 4 more miles added? Well, obviously, if it says adding, adding is one of those key words in math that mean you're going to stick a little plus symbol. I mean, that's pretty straightforward, I think. Okay, now we're adding 4 miles per day, and it says we're going to use capital D for the number of days. Okay, so there's our equation. There's our equation that models the word problem, the scenario that we've got. And so now it asks us to use the equation to find the length of the road after the crew has worked for 32 days. Okay, well, 32 days has to be the value of either L or D. Those are my only 2 variables. So is 32 the length of the road in miles total, or is 32 the number of days? Well, it says 32 days. It's pretty straightforward. So we're going to substitute 32 in for days, okay, which gives me the equation looking like this now. L equals 53 plus 4 times D, but we know that D here is going to be 32 days. All right, so all we have to do now is just evaluate, simplify the right side of your equation. So L equals, now 53 plus 4 times 32. All right, I know that somebody is going to do 53 plus 4 if I gave you this on a quiz or a test right now. And I hope that some of you are at least thinking, wait, he can't add before he multiplies, right? Because if you remember PEMDAS, multiplication comes before any addition, okay? So we're going to multiply positive 4 times 32. So bring the 53 down, plus 4 times 32 is 128. So that means that the length of the road in miles after 32 days is going to be 53 plus 128, which is 181. Don't forget your label, okay? Your label for L is in miles. So MI is the abbreviation for miles, or you can write the whole word miles out. But 181 is going to be your answer. Okay, let's go to the next section of our notes. Okay, we drop down, we've got example number 2. The Sugar Sweet Company is going to transport sugar to the market. It says it's going to cost $7,500 to rent trucks, and then it'll cost an additional $150 for each ton of sugar. Right? Now for the variables, it says let capital C represent the total cost in dollars, and let capital S represent the amount of sugar in tons that they're transporting. So the first thing it says is write an equation relating C to S. Well, which one is the dependent? Which one is the independent variable? Right? Well, look back at the previous two examples that we looked at. And if those give you some hints, I hope they do. I mean, your dependent variable will be here. And then you're going to have your initial amount here. What's the initial amount? Well, we're talking about the cost to transport sugar to market. So the initial amount is given to you, okay? And that is the 7,500. That 7,500 doesn't change no matter how many different tons of sugar are being transported, okay? It's going to cost $7,500 to rent the trucks no matter what. So that's an initial fixed cost. So my 7,500 goes right here. Right? Now the next thing we're going to have is the rate of change. Right? Now, rate of change is going to be per or for each something. Right? So like per week, per mile, for each lollipop, for each pizza, for each pair of shoes. Okay? And if you look here, $150 for each ton of sugar. Okay? So 150 is going to be your M, your slope. Right? Is it going to be positive or is it going to be negative? Well, it's an additional. Additional. Add is in additional. You're going to add 150. But it's not just 150, it's for each ton of sugar. So which variable represents how many tons of sugar we have? Okay, well, there's the in tons. So S represents how much sugar we have. I'm going to change the color for the variables here. There's S. And if you take 7,500 for renting the trucks and you add 150 times the tons of sugar that we transport, that equals what? That equals the total cost in dollars for us to transport all of that sugar to market. Okay, here's our equation. Sweet, we got the equation. All right, now, then use this equation. You got it, you might as well use it. Use this equation to find the total cost to transport 17 tons of sugar. No problem, okay? 17 is the number, tons of sugar. Okay, so are we substituting 17 for C or S? Well, if you look up here, it says tons of sugar is represented by S. So let's go ahead and substitute 17 for S. Okay, so my equation is going to look like 7,500 plus 150 times 17. Okay, so let's start simplifying a little bit. Okay? We know that we have to multiply before we can do that adding. So 150 times 17 is 2,550. Okay, now we will simply finish up by adding those two numbers. And we got, let's see, we got 0, we got 5, we got 10. Yeehaw. So it's 10050. Okay, but let's clean up our answer and make it a little more relevant. Okay, first off, capital C is in dollars. So we're going to have a dollar symbol. And also it's 10,050, so let's put our comma in. Okay, so to transport 17 tons of sugar, we use this equation, and we decide that we are going to have to pay $10,050 to transport that much sugar to market. Okay, next page. Right, example 3. All right, we're filling a small pond with water, right? They're adding water at a rate of 30 liters per minute. The rate, I'm telling you right now, every time they give you a rate of change, that's going to be your slope. So if you're thinking about y equals mx plus b, which is a great thing to think about, that's always going to be your m. Okay, that's going to be the number in front of your letter, the coefficient of your independent variable. There are 500 liters at the start. So that's my initial amount. That's my fixed amount that we start with. And now we're going to add on to it from there. Right? And it says let W represent amount of water in the pond in liters. And it says let T represent the number of minutes. Right? Write an equation and then graph your equation. So let's write our equation first. So we have our dependent variable equals our initial amount, right, plus or minus, depending on whether it's an increase or a decrease, my rate of change times my independent variable. Okay, my dependent variable equals my initial amount plus or minus the change, the rate of change times the independent variable. Okay, so what is our dependent variable? Well, we only have two variables, W and T. So do the number of minutes depend on how much water we have, or does the amount of water we have depend on the number of minutes that have gone by? Well, the water depends on the minutes. So the W is going to be my dependent, okay? Which means that the number of minutes is my independent. So this right here, independent variable, bingo. Okay, initial amount. The initial amount says that at the start, we start with 500 liters of water. Okay, switch that up, 500. Now the change, it changes by a rate of 30 liters per minute. So is it changing by positive 30 or negative 30? Is it rising or is it falling? Well, it's filling the pond. It didn't say it's emptying the pond, it's filling it. So that means it's going to be plus. All right, so there's our equation. That's our linear equation. Now it says draw a graph of this equation. And there are a few ways that you can graph lines. We've done them in previous lessons. You can do the y-intercept first and then do rise and run if the numbers are small or nice and right on the grid. This one, they're not. So I would probably choose doing a chart, the little XY chart, or in this case, TW. T is on the x-axis. They even showed it as the x-axis. It's my independent variable. W is on my y-axis, my dependent variable. So let's pick an easy one. We know that when T is 0, we had 500 liters. And yes, 500 plus 30 times 0 is 500. So 0, 500 is on our line. 0, 500 is right about there. Pretty close. Cha-ching. Okay. Let's pick another point that's nice. Make sure that the point is going to be on this graph. The graph goes from 0 to 9, even though 9's not there. So let's keep the numbers between 0 and 9. So we did 0. Let's take, I don't know, let's take 1. If t is 1, 500 plus 30 times 1. Well, 30 times 1 is 30. 500 plus 30 is 530. Okay, so we go to 1, and then we go up 530. Now, your grid has 500 and then 600. So you're going to have to estimate a little bit here. So it's less than half. I'd say it's somewhere around there. Okay. Somewhere on that spot. I'm going to do one more. Let's pick 5. It'll be on here. So if t is 5, 500 plus 30 times 5. 30 times 5 is 150. 500 plus 150 is 650. So I come over to 5 and I go up 650 units. And 650 is going to be right halfway between 600 and 700. So right in there. And so I'm going to connect my dots. See if I can do a little better with my arrow. There, probably better. Okay. So you only need 2 points to establish a line, but I would like to have 3, just because then I could tell if one of the points is wrong, and I only do 2 points, then it's going to be a wrong line. But if I see 3 points that are not collinear, then I can go back and fix one of them, right? But this is a good looking one here. This is all pretty linear. We have one more example. Let's get right to it. Let's drop down to example 4. And with example 4, for some reason, the Alex questions really like the Sugar Sweet Candy Company, which, hey, you know, I like candy too. Sugar sweet, it's all nice. So it asks us to, again, write an equation relating the 2 variables. So let's see what it says. The Sugar Sweet Company is going to transport its sugar to market. It's like deja vu. It will cost $4,550 to rent the trucks, and it'll cost an additional $175 for each ton of sugar transported. Okay, so we're going to let C represent the cost in dollars, S represent the amount of sugar in tons. So let's get our equation right here. Dependent variable equals the initial cost or initial amount plus or minus the rate times the independent. Okay. Go back and rewind and replay that again if you want. I'll just say it one more time. Dependent variable equals the initial amount plus or minus the rate times the independent variable. Okay, so what is the dependent variable? Well, does the cost in dollars depend on the amount of sugar, or does the amount of sugar that is transported depend on the total cost? Well, the total cost depends on and relies on how much sugar we are going to be transporting. Okay, especially since up here it says that the sugar is going to be changing, and because the rate is going to be affecting the sugar, it's going to be my independent. We're going to plug that in. All right, so that tells me that the cost, C, is my dependent variable. Now, my initial amount, okay, the initial cost is $4,550. So 45.50. Now, plus or minus the rate of change. Okay, what's it going to change by? Well, it's going to change by $175 for every ton. So I know that there's going to be a 175. Is it going to make your cost increase or decrease as you get more and more tons? Well, it says additional. So we're adding $175 for every ton of sugar, and S represents the tons of sugar. So there we have our equation. It's nice. And I'm looking over here and I'm saying I really don't want to do rise over run with 175 because these are not in increments of 175. Those increments are actually in 500 unit increments. So let's go with our S and C. Start with 0 because that's easy enough. If S is 0, 175 times 0 is 0, plus 45.50 is 45.50. So let's estimate. 45.50 is just a little bit above 4,500. So we start at 0 and we go up 4,500 and then a little bit more for 45.50. So right in there. Okay, let's go with S is, oh, I don't know. Let's go with 2. Okay, if S is 2, 175 times 2 is 350, plus 45.50. I do believe that's 4,900. Okay, so let's plot that point. So we come over 2, and then we go up 4,900 units. So that's between 4,500 and 5,000. So it's just a little under 5,000. So right in around there somewhere. And let's get one more. Yeah, let's go with 4. Okay. So if I take 175 times 4, I get 700. So add 700 plus 45.50, and I get 52.50. So I come over to 4, and I go up 5,250, which is halfway between 5,000 and 5,500. Connect your dots. It's linear, it's going on to the right. So I put my arrow. All right, and that concludes day 4 notes. Hope that this was clear to you. Go use your rewind button, replay as much of it as you need. If you're still not clear on it, feel free to reach out. You know how to get in touch with me. So that's it for day 4. See ya.